So firstly, can everybody see that?
Yes.
Perfect. So yes, as was mentioned, I'm Dan Faulkner, work for Tata Steel UK. Usually I'm based in Sheffield, but I happen to be on a work trip at the moment, hence the hotel. I'm just a couple of kilometers away from the main steel making site of Tata Steel UK, down in Port Talbot, South Wales. Um, so what is going to be presented here? I firstly wanted to start off with introducing the global steel industry and steel making processes as well, to give that context to those who might not be familiar, and also talk a little bit about Tata Steel UK in particular. Then I'll introduce some sustainability themes in the steel industry. Basically, what do steelmakers care about? What are their focal points of sustainability? And then finally get on to talking about what are the sustainability practices in the steel industry. And I guess the aim of this presentation is for people to firstly gain an appreciation for sustainability priorities of steel companies, get a bit of an insight into industry practices, and hopefully be able to take away some concepts and ideas that might be transferable or applicable to your own industries. So the kinds of practices and topics that I'm going to cover are those such as greenhouse gases, a little bit on ISO standards, not too much, a little bit on disclosures and reporting, sustainability in product development, environmental product declarations, which is something that I'm quite familiar with, responsible steel, and then the role of digitalization in sustainability. So firstly, looking at the context of steel making in the steel industry. For those who are not familiar, this is essentially a flow diagram of the main steel making processes. And usually it's divided up into two main processing methods. The first being, I guess, the more traditional method, which is blast furnace steelmaking, which takes iron ore, coke, which is made from coal, and limestone, puts all of those into a blast furnace to make iron, and then the iron is put into a basic oxygen furnace to get rid of some of the carbon that's in the iron, and turn it into steel. And then that steel is taken further processing steps until you get your first cast steel products. The second main route is via an electric arc furnace, and generally this route is referred to as scrap-based steel making, because the primary input is recycled steel or steel scrap, placed into an electric arc furnace, and then further processing done to that liquid steel to turn it into the first cast solid products there. And direct reduction is another method and part of the picture, I suppose, in a technology sense, but not quite so common today. And also just to point out that pig iron casting, which you can see on that diagram, is not necessarily a step in steel making, and certainly not a step in integrated steelworks, which would just take the liquid iron straight from the blast furnace and start making steel with it. So a few numbers about the steel industry, just so you get an appreciation, I suppose, for the scale of it. Global steel production, approximately 1.8 gigatons per year, or 1.8 gigatons. And steel production accounts for somewhere between 7 and 9% of global anthropogenic or man-made CO2 emissions worldwide. So a huge contributor to those emissions. It's also the most recycled material in the world, and demand and subsequent production is projected to increase. Those are some of the main steel companies, and you might recognize a few of them. That diagram just illustrates the rising production of steel, and those were 2023's figures, so 1,849.7 million tons of steel produced in 2023. So where is steelmaking headed? Taking the iron and steel technology roadmap from the IEA, you can see how technologies, the balance is predicted to change. Firstly, between 2019 and 2050. Firstly, from what's called a current policy view in the middle bar, where you've got slightly more EAF or electric arc furnace steel being made from scrap. But really what this report is trying to say is that there needs to be a more balanced variety of technology in the steelmaking industry to get to a sustainable development scenario in steelmaking. And the image on the right hand side there just illustrates a few of the routes into producing steel more sustainably. And I'm not necessarily going to talk about the technology per se in this presentation, but you can find information on that. And actually, myself and some colleagues did do a presentation on the technology of steelmaking for IChemE, if you're interested. I just want to mention the World Steel Association, which is our global industry body. Its membership covers around 85% of global steel production. It's basically the first port of call if you want to find out data on steel companies and what we're up to. But its goal is really to promote sustainable steelmaking and be a focal point for strategy as an industry. And like I said, is a very large source of data. And World Steel has got its own interpretation of what should be the focal points. You can see them there. You've got climate action, responsible value chain, life cycle thinking and circular economy, water management, and air quality as being it sees as the focal points of sustainability in steelmaking. And World Steel does have its own initiatives to do with sustainability, which steel companies can work towards. So Tata Steel UK, just a bit of context on the company that I work for, is currently the largest steelmaker in the UK. Covers a variety of geographies, including Norway and Sweden as well, but primarily supplies into UK markets and a variety of markets as well. As I alluded to earlier, I'm currently sat just down the road from Port Talbot Steelworks, which produces around 3 million tons of steel per year. So hopefully from all of that, you've got a bit of an appreciation for how steel is made, the scale of the global steel industry, an awareness of the World Steel Association, and also a little bit of information as well and context on Tata Steel UK. So now I'll talk about what are the most pertinent themes of sustainability within the steel industry. So I divided them up the way I saw them into the sort of classic environmental, social, and economic pillars, you could say. So we'll start with environmental. Decarbonisation, of course, being a huge focal point of the steel industry. As I mentioned earlier, the industry is a massive contributor towards global man-made CO2 emissions. So a lot of effort is put into looking at different routes to decarbonizing different parts of the steel life cycle and supply chain. And energy optimization kind of links in with that. I've listed out a couple there, but just to also pick out scrap use and recovery, which is also linked a little bit in with the yield of processes, is also a very big focal point, not just from an environmental perspective, but also financially as well. The more steel scrap you can prevent making, the more efficient the processes are, of course. So steelmaking, I hope you've got a kind of appreciation of the scale of it at this point. And in order to produce those massive volumes of steel, which is demanded by the world, there is a large amount of material that's required to go into the plants to make steel. So supply chain traceability and responsible sourcing are two really big issues for steelmaking companies. And steelmaking as well, as I'm sure a few of you will be aware, is historically very entrenched in the communities or connected to the communities that it impacts and serves. And also steelmaking sites have a huge land footprint. So having that and maintaining good relationships and engaging with the communities that are impacted is also something quite important to steelmaking companies. And of course, to enable all of this to happen and to continue serving customers, like any other company, we need to have a sustainable plan for maintaining financial stability. And I kind of took that list of sustainability themes or priorities and try to draw, I guess, a list of practices which might address them. And I thought as a kind of exercise there, it was kind of interesting that as I was listing them out, that almost all of them were affecting multiple different pillars, not just environmental or social or economic, but all three of them together. And these are some of the ones that I'm going to be talking about later in more detail, but I'll just finish off this section on sustainability themes before I do that. I thought I'd bring up World Steel again and their own interpretation of what sustainability themes are in steelmaking, but also mention responsible steel, which is a fairly new standard, steel industry specific, and that looks at 13 principles of sustainable steelmaking, or what it means to be a responsible steelmaker. And you can see there that you've got a pretty holistic view of sustainability there, with governance principles, social principles, and environmental principles in there. And those are, as I said, what Responsible Steel sees as the most important things for steel companies to be focusing on. Before I get into practices, I want to highlight as well, and I know this is a very busy slide here, but I've highlighted a few things that there's a few organizations and initiatives that are quite important to steelmakers, certainly Tata Steel in particular. So you've got their science-based targets at the top, which is essentially an initiative that sets out how to set targets which are backed by science, that aren't just kind of a random target in the wind, if you want to call it that. And that's not a steel specific one, but is nevertheless something that that is being looked into by Tata Steel UK. Responsible steel, I've mentioned, and we'll talk about more later. On the sort of policy initiatives, two quite recent ones that are becoming more and more relevant to us, and certainly more relevant to companies operating in the EU and India respectively, are the CSRD and BRSR, two acronyms I know, but essentially they set out some reporting requirements which are mandatory, statutory, and those statutory requirements are becoming a kind of increasingly prevalent theme, not just in the steel industry, but is nevertheless something that we're now seriously looking at, trying to satisfy. CDP down there is something that I'll mention later, Carbon Disclosure Project. I've mentioned World Steel already, and then you've got next to that the GHG, or Greenhouse Gas Protocol, a global standard for the reporting of greenhouse gas volumes. EPDs, which stands for Environmental Product Development Declaration. Again, something I'll talk about later. And then you've got TCFD, which is the Task Force for Climate-Related Financial Disclosure, which is something that we are looking at and have looked into as a result of the two circled above, the reporting requirements of CSRD and BRSR, both of which I'll talk more about later. So with that section complete, I hope you've got an appreciation for some of the most important themes of sustainability in steelmaking, and also a kind of general awareness of some of the organizations which we work with and we might submit data to that support sustainable steelmaking. So now getting into actually what some of the practices are in the steel industry from a sustainability sense. And in making this presentation, I kind of put some of these practices into 9-ish categories, just so you know what to expect, of things that we do that support the sustainable making of steel. And kicking off with, I'm really sorry, but ISO standards, and I feel like it's somewhat of a bad idea to maybe bring up a quality management standard to the Chartered Quality Institute, but it's nevertheless extremely important for us to maintain that on all of our sites, so that customers, stakeholders know that we have responsible governance systems in place at those sites, and that we're doing a good job of managing ourselves and managing the way that we operate. I'd mention as well ISO 14001, the environmental management standard, which people definitely look at, certainly when it comes to how we might deal with air, water, air emissions, our water usage, and the way we manage that, and the governance surrounding the way we manage our sites environmentally. That's definitely something that customers and other stakeholders care about. But what's perhaps an interesting thing with these two is that they also get used by other certifications, and I've picked out BES 6001, which is a construction standard, which we try to get certified with, which, as part of it is a responsible sourcing standard, looks at who in your supply chain has 9001, has 14001, what percentage of suppliers have these, and uses that as a metric for determining how responsible your sourcing is for raw materials. So moving on to more of the disclosures and reporting, I've mentioned some of these already, but just to point out that the permits, of course, it is essential to meet um, uh, the permits which we're regulated against, whether that's air emissions or the um, or meeting the requirements of the UK emissions trading scheme, which involves accounting for the amount of CO2 that we're putting out. And I also put down there one of the main regulating bodies which we communicate with and that we're regulated under, which is Natural Resources Wales, who keep track of all of our permits and make sure that we are in line with all of those too. Also to mention more corporate reporting side of things, I've picked out a few there. CSRD, which stands for Corporate Corporate Sustainability Reporting Directive, and BRSR, which is the Business Responsibility and Sustainability Report, which were generated from the EU and India respectively, place a huge requirement on the disclosure of sustainability related metrics, from how you are sourcing materials to your carbon dioxide output, from your water usage, your air emissions inventory, to your lost time injury frequency rates. And it is a significant effort that's going into meeting those kinds of reporting initiatives, both of which were actually influenced by the Task Force for Climate-Related Financial Disclosures, if you're interested to find more about those two corporate reporting initiatives. In relation to that, the UK is actually producing its own version of these, called the Sustainability Disclosure Standards, or SDS. The next kind of information about this will come out in July 2024. So if anyone on the call is working for a company that has significant operations in the UK, this might be something that you might want to keep tabs on. Certainly, if you're working in the field of corporate sustainability. Next up is the practice of voluntary disclosures, and there are many benefits to disclosing information voluntarily towards these organizations, but various others too. I've picked out the World Steel Association because we submit a lot of data to them, and they take data from all over the world from various steel companies, and turn it into life cycle inventory reports, which we can then look at, essentially find out our place among other steelmaking companies. It's all anonymized, but they point out to you where you sit among that data. So it's incredibly useful for us to find that out. And then you've got initiatives like CDP and EcoVadis, which are essentially things that look at sustainability of a company, not just steel, but sustainability of a company more holistically, look at a wide range of issues, from climate change to water to air emissions to people management and the governance processes surrounding all of that, and communicates via, it might be a rating. I think EcoVadis does a gold, silver, bronze. CDP is more of a kind of A to B to C sort of thing, but they communicate to stakeholders essentially how much how responsible is a certain company, how sustainability minded as a certain company? Is this a company that you want to be associated with and dealing with according to the metrics in each of the initiatives? And companies do directly ask us about certainly these two things. So is definitely a practice that we uphold is disclosing information towards these. And just to sort of round off the whole reporting and disclosure section of these practices is just to mention the I suppose the more recent practice of integrated reporting, which takes the requirement for all of these different kinds of disclosures, where it's voluntary, where it's if it's needed by the board or a certain stakeholder group, or if it's something like BRSR, which I mentioned, which is a whole separate report in itself, and financial reporting, of course, and puts them all into a single document. And it enables individuals to get a complete picture of the company in a single place and access a single source of truth. And the screenshot I've put here is of the Tata Steel Group integrated report. And if you're interested in looking at what an integrated report looks like, it's actually fairly decently formatted, and I refer to it actually all the time in my job, and it's got a lot of good information about the company in there. If you're interested, it can be very easily found on the internet. So responsible steel is quite an interesting one. It's steel specific, as I mentioned previously. It has its own holistic view at what a responsible steel making company should be, what a sustainably minded steel company looks like, and has these 13 principles to measure it against. And you might be picking up this point, and you might be aware of already that there's loads and loads of different organizations which might rate a certain company on its sustainability metrics, on its climate change performance and targets, and everything. And reporting to all of those is genuinely a challenge. So responsible steel's pitch and reason for existing, it kind of aims to be the one-stop place for customers of steel companies, for anyone who wants to find out about steel companies, to find out how responsible each steel company is. And it aims to overcome that issue of many kind of organizations for steel companies to be submitting data to and or be audited by. And one of the things that helps it do that is being compatible with various ISO standards that a lot of steel companies or companies in general might already have, such as 9001, such as 14001, such as 45001, which is an occupational health and safety one. And all of that is taken into account in responsible steel. So it becomes this sort of one-stop place to find out how sustainable and responsible a steel company is. So I don't know if, you know, in some of the industries that people on the call work in, if there's something similar, but it'd be interesting to hear if there is something out there like that.
I think we can take some questions after.
Okay.
But on your comment, yes, they are very similar. I come from construction, so in construction we are very similar, and we support the three main standards: 9001, 14001, and 45001.
Yeah.
But you touched on responsible sourcing, and we also support BES 6001, which is looking at raw material supply chain and a number of those elements. So I would say there are very many similarities between different industries. It doesn't matter if it's automotive or construction or aerospace. Certainly, the agenda is very, very similar.
Yeah.
Behind these incentives.
Yeah. Well, it's interesting to hear, and yeah, I know a bit about BES 6001 myself. I assisted with the audit for TS UK last year and will do again this year. So yeah, there are definitely some similarities with Responsible Steel in that regard. So as I alluded to earlier with talking about decarbonisation and the massive impact that steel industry has globally and contributes towards the global greenhouse gas emissions, it is an incredibly big focal point of the industry. And like many other companies, we set targets, make great attempt to measure and calculate carbon emissions, and also expend great effort to make sure that we're reporting in a responsible manner and disclosing the energy and carbon in relation to all of that. And I suppose in conjunction with those three things is of course, the necessity to look at how we reduce carbon emissions. And it's a crucial part of any steelmaker's long-term plan for sustainability, and is incredibly important to many stakeholders. Steelmakers taking up generally quite a large portion of the steel supply chain, in that we purchase a lot of raw materials, and because they're in such volumes, might also have things like chartered ships, which are under our own responsibility, have that side of the supply chain, have the steel making side, the raw steel making side of it, of course, as well, that might involve the use of a blast furnace or electric arc furnace, as I mentioned, and then also might have their wholly owned downstream facilities which take that raw steel product, which might be in the form of a slab or a steel strip, and turn that into products which are more industry specific. So we've got the opportunity to make lots of make lots of different kinds of reductions along the life cycle of steel, from the materials purchased, the technology used in steel making and downstream processing, in the kinds of transport and the transport networks that we use, the energy types used, which might include what kinds of fuel are we putting into our own transport, designing for end users and fabricators in mind, so that their operations are less energy and greenhouse gas intensive. So there's a lot of things that we can do, and a lot of things that we look at, and it would really take a long time to go into each of the different opportunities there, but just to kind of mention that there's a lot of opportunity to do so. Sort of coming on a little bit from that in terms of perhaps the designing for end users and fabricators. This is something which I know some companies do. I don't necessarily know about other steel companies, but having a sustainability assessment as part of our new product development process is something that has become increasingly standard practice within Tata Steel UK. Again, I'd be interested to hear if this is something that other companies do, but basically it involves a qualitative sustainability assessment or questionnaire during the new product development process, evaluates products against a product baseline, multiple criteria from environmental, social, or financial within different life cycle stages. And I've sort of taken 2 screenshots above there of some of the questions in the manufacturing stage, and then some of the questions in the fabrication stage, which is, might be a downstream fabricator, that looks at, does in making this product compared to the old one, does it use more hazardous chemicals? Does it use more water? Does it enable more highly skilled jobs in the local area? Are there additional health and safety risks in the supply chain when making this new product? Does this new product, is it easier or harder for the fabricator to then make something out of? So looking at all areas of the life cycle, and once all of that is filled out, goes into creating this kind of feeds into this profile on the left hand side, which kind of communicates all of the pros and cons in each of the different areas and life cycles to whoever we need to. And it is really, really useful for communicating, first of all, but does enable quite useful comparisons to be made to existing products. Life cycle assessment is something that is used quite a lot by steelmaking companies. And if you don't know what life cycle assessment is, it's basically a quantitative method of evaluating the impact of any product has on the environment across its entire life cycle. And it's used to understand the significance of impact at different life cycle stages for different impact categories. So that might be the impact on climate change, so the amount of CO2 that's produced as a result of this product being made, might be the amount of sulfur dioxide or acidification impact that a product may have, water use, waste, primary energy use that goes into making this product, and is incredibly useful for hotspot analysis. So looking at the significance of different impacts at different life cycle stages, and incredibly fundamental to the production of environmental product declarations, which are a kind of environmental profile, and I guess it's more of a construction focused thing, really, but it shows the impacts that a product has across the life cycle, stage by stage, uses life cycle analysis to compute all of those impacts, third-party verified. Again, an excellent communication tool. Also a necessity for supplying into some countries and projects. So these documents, which contain environmental impacts, are actually sometimes absolutely necessary to be able to sell a product. Otherwise, a project might not want to take our product if we don't have an EPD to show them. And again, if you want to look at some of these, they're available on many companies' websites, many steelmaking websites. This is just a little extract, so you can see what one looks like in terms of the how it's presented. This is one that I actually did for Tata Steel UK. You can see that it's got the different impacts across the different life cycle stages, in an absolute sense or relative, and is a really good way, I think, for viewing the impact that a product has on the environment. And this is the final thing that I will mention. I want to talk about digitization, and sustainability. And I do try to attend myself a lot of talks and webinars. I do feel like digitization is sometimes a word that's sort of thrown around a bit as a sort of solution to optimizing everything. But nevertheless, when you've got a greater and greater volume of data that's been required by different initiatives or different statutory reporting requirements, you really do need to be able to collect, monitor, analyze, and report that data for multiple purposes. And digital solutions can help to address this, as well as help inform decisions, and take actions. And just from anecdotal evidence, there does seem to be a greater and greater amount of companies out there that have software or digital solutions for managing all of this data related to the sustainability profile of a company. So I want to give two examples of this so you can actually see how some of this has helped Tata Steel UK in particular. And one of the ones that I want to bring up is a system that we call MONICA, which is a very, very loose acronym. It stands for Monitoring CO2 Emissions and Energy Consumption Abatement. Basically, it's our system that we use for tracking the CO2 output of all of our sites, even sometimes down to plant area. And of course, you need all of the measurement equipment in place to be able to provide all of that data. But in supplying into MONICA, we're able to track material in and out of each plant or plant area. And then the balance of carbon content across each plant. So the carbon content of the stuff going in and the stuff going out, it takes a balance of all of that. And the difference between that is what is assumed to be the CO2 emission. And similarly with the energy, it takes a balance across, say, a site, and then the energy consumption will be the difference between the energy contents of the streams coming in and out. And this is incredibly useful for getting an understanding of CO2 emissions and energy usage at different sites in different plant areas, what fuels and materials and energy flows are causing or being responsible for CO2 emissions and energy usage. And within the system, we can get a really nice breakdown of our steelmaking site. And what's really useful about it is that everything that goes into MONICA is archived and date stamped, so that if we want to make comparisons between, we might make an adjustment to a method in calculation or the data that's actually contained in MONICA, the most recent and live data. So the fact that we've got a database behind this that supports MONICA is really, really helpful for making those comparisons. And I want to mention, I've sort of got quite generic photos and information on this one because this is an ongoing implementation. But one thing we're also trying to do is implement a reporting platform for all of this data related to what's called non-financial data or data that would be related to forming a sustainability profile of our company. With so much data, it's become almost a necessity to have something that can take all of that and form reports for that for various different organizations. But this is the idea is to also provide a central location for that data and crucially provide a visible audit trail for assurance, so that when we get people coming in looking at the validity of certain numbers, they can easily track where those have come from. And also, I mean, just as an aside, it has been a really good kind of learning exercise for learning about our different systems, and getting the consolidation of metric definitions as well, which is not something that was has necessarily always been done in the past. So yeah, that's an ongoing thing, and we'll see how that goes. And that sort of brings us to the summary of this presentation. So to, I guess, summarize everything that I've talked about there, key points from part one being the explanation of the steel making process itself, and getting a bit of an appreciation for the scale of the global steel industry. Hopefully you've got an awareness now of the World Steel Association, and definitely go there for any further industry information, and also giving you a little bit of context on Tata Steel UK. Key points from part two, which was on the sustainability themes. Hopefully you've picked up some of the important themes of sustainability in steelmaking, and also a little bit of an awareness of some of the organizations and initiatives that support sustainable steelmaking. And then from part three, the practices, I explained a little bit about the ISO standards that are most relevant to us, relevant mandatory and voluntary disclosures, integrated reporting, a little bit about responsible steel, GHG emissions, and the fact that it's such a big focal point for us, and the kind of things we do surrounding that. And then a little bit about sustainability assessments, then life cycle analysis, and the importance of environmental product declarations using life cycle analysis, and then that little bit at the end on digitization in sustainability. So with that being the end, is there any questions?
Oh, thank you, Daniel. That was very good. It's a very complex process route, as I know, and very challenging exercise you've got there. Lots of the slides were very busy. Obviously, because the thing's been recorded, people will be able to go back to those. But I think you've covered it extremely well. So much information there that it was just hitting you in the face. What really strikes me is that although the steel industry is big and what have you, you've pointed the way for other people to, perhaps on less complicated industries, to actually, well, look, there is an approach you can take. You've demonstrated the approach very well. So without going into too much data, I think as the thing's going to be available, people are going to be able to access that and really pick up the route. It's been very courageous of you to come forward and do this.
Thank you.
I've got one question myself, which I've got 40 years of electric arc steel making experience behind me, and it's not going to be an easy shift for you to go to electric arc furnaces, because you've got a basic oxygen furnace, which is what, 300 tons, 350 tons, in which case you're going to need an equivalent amount of electric arc capacity, which you're talking about probably a 250 MVA transformer, a lot of electricity being used, sort of half a turbine generator's worth from an old thing. So getting hold of that amount of electricity, I guess, is going to be one of your problems.
Well, I think if a public relations advisor from Tata Steel UK was looking over my shoulder, he probably advised me just to
duck the question.
Yeah.
I'm sorry to I'm not trying to catch you out. I'm just
No.
pointing out that it looks quite easy on paper, but practically it's going to be more difficult to deliver.
I mean,
Uh,
a challenge to be sure, but
Somebody
hopefully
in your organisation must have thought about it. It's just I've no contact now, obviously, because it's 23 years since I retired from full-time work. So
which companies did you work for?
British Steel. I was Stocksbridge. I was based at Stocksbridge and
Yes.
Rotherham.
Okay.
So and the Shetcote Lane Stainless Works as well.
Yeah.
But I've been around steelworks all over the world, going from North America to Russia, Sweden down to South Korea. So, but they're all electric arc shops. As well, I've visited Scunthorpe and Ravenscraig when it was open, and Scunthorpe. So I've been to the South Wales ones as well. But it's a big challenge you've got, but I see you're tackling it very well.
I think
Any more questions?
Excuse me, Hugh. It's Rob Gowling here from British Steel, of all places.
Yes, Scunthorpe.
Going back to your point, we're actually obviously doing the same thing.
Yeah,
but
yeah.
We've been looking at, if you go for a really big electric arc furnace, to get the power, it's going to take nigh on a decade. But if you go for a smaller 1 million ton a year vessel, we reckon, our numbers are in that it's going to take 2 years to get the power sorted out.
Yeah,
but you also have the other side that you've got no arising gases anymore.
Yeah.
So we're having to look at projects to bring natural gas onto site as well.
Yeah, because you lose the blast furnace gas.
To keep the mills going, and we can't afford to stop running the mills. So we've got to try and fast track that project before we can even think about bringing the blast furnaces off.
Yeah, well, Rotherham could make, when it had got 250-ton furnaces, that could make 1 million tons a year. So 250 tonners would probably do you for 1 million tons a year.
Yeah. But I think, Daniel, it's nice to see someone else looking at Monica, because that's one of my. I'm the only person in our business at British Steel that knows how to use the thing, and I'm still learning,
though, isn't it?
Yeah, it can be a very useful tool. Yeah.
I think there are two challenges when you look at the energy. First of all, because the incentive from the government is looking at the net zero carbon for 2050, a lot of the industries have pretty much split to reduce their carbon 1/3 by 2030, 1/3 by 2040, and pretty much to go to net zero at 2050. So the challenge you have is that the grid, if everyone is going to electricity in one go, cannot hold and supply so many different industries at the same time. That's the first challenge. And also a lot of the facilities cannot take that level of electricity and supply it at the right processes in the plant. So it will require substantial capital expenditure on top of that, assuming you can get it in the first place. And the other thing is that when you compare countries like Finland or other countries abroad, the electricity is a lot cheaper. So you will require substantial operational expenditure if you decide to go to electrical sources to deliver the zero carbon activities. So the operational capital expenditure will be very, very high. And unless the companies are willing to accept and pay for that, it will be very challenging to justify big capexes to actually deliver that net zero carbon targets. And in some countries, it's first come, first served. So whoever now goes and gets the biggest chunk out of the grid, at least they secure the supply. Whoever follows after, they will have the challenge to try to secure the same level of electricity, because the grid cannot supply that. One question I had, Daniel, and you talked a lot about circularity, and it was a very good presentation. Thank you for taking the time. In construction, we have big problems recovering raw materials. So when you talk about recycling, I don't know how big the recycling still is at the moment. Do you find it easy to go out there and try to manage and bring all that scrap back to be able to recycle it? Or is that a very big challenge? I don't know how much is out there for you to try to claim and stop using natural sources.
Yeah, I mean, that I wish I brought along some steel recovery rates, because you know, the numbers are out there, but generally they are quite high certainly comparing material classes. The fact that steel is magnetic makes it actually an incredibly easy material to recover from mixed waste streams, and because steel scrap is such a valuable, it's a commodity. Everybody wants it because it reduces the kind of overall carbon intensity of the steelmaking process if you use more of it. So with the combination of the ease of recovery and the motivation to recover it, a lot of it does actually get recovered.
I see.
Yeah, I think there was one thing in the UK at the moment, we're exporting 10 million tons of scrap every year.
Yeah.
So more than enough to go between us and Tata.
Yes, yeah.
I think there's another electric arc business wanting to set up in Aberdeen, because they want to take all of the oil rigs from the North Sea and recycle them actually in Aberdeen. And that was a 1 million ton a year project up there with another company.
The problem you've got with scrap, it's a very variable item. You get a lot of pickup of residual elements that you don't want for certain grades of steel. With
we don't want
with the alloy steels, we could regularly get up to 0.3% copper, which effectively nearly everything was core 10 if it was just a carbon steel. But no, it didn't matter with a lot of the steel alloy steels, but things like antimony and arsenic and phosphorus and tin were very bad for high temperature properties and things like that, and also for formability for things like cold-headed bolting and what have you. So scrap can be a very variable quantity. It's very difficult to stop people throwing electric motors in, for example, and live ammunition at times.
And radioactive sources as well.
Yeah.
Contamination with radiation.
Yeah, that's it. Yes, you need special radiation detectors, and even got to put them on the grabs that are lifting the scrap out, because you can't get it with just this straight one above and one below. You need to surround the scrap.
Yeah, I've already got those on site, so.
Oh yeah, well, yeah. See, you went to the same lecture that I went to.
Maybe.
I believe that Elif has the hand raised. Is that correct?
Yes. Hello, everyone. I mean, there's a question just came to my mind, and I would like to, as I'm also working in one of construction industry and a quality file. So I just wondered that in terms of the reducing carbon emissions, so does it affect any quality of the product?
In what sense? If is there any particular kind of reducing of carbon emissions project that you have in mind?
No, but I mean, for instance, to reduce while producing something, especially in the steel industry, so considering reducing carbon emissions, so does it affect also on the product quality itself? Has this been investigated? Or, for instance, I mean, to be reduced carbon dioxide emissions, so we may short the process. A few process. I cannot say which process is that, but I mean, does it affect also the outcome of the product?
Are you talking about?
There's a question.
Sorry. Are you talking about constructional steels, the basic constructional steels?
Yeah, it's general steels. Yes, for the construction.
The general steels. Yeah. Well, it depends which type of steel you're talking about. I guess the guy from British Steel at Scunthorpe, they make quite a lot of or used to make a lot of constructional steels, whether they still do or not. He might be best to comment about how the change in process route would affect that.
Okay, Hugh. We wouldn't be worried so much about constructional steels. We'd more be worried about the rod we make and the rail. From a quality perspective, and also it is a problem that will build with time, because we'll put it through the electric arc furnace once, and then in 20-30 years time we're going to put that same product through the process again and again, and gradually over time this steel will have all been recycled 2 or 3 times, and the impurities are going to build up each time it goes through the electric arc furnace. So one of the things we can actually do is add in iron or pellets into the electric arc furnaces to try and reduce or dilute out some of the impurities. But obviously be very careful about the scrap steel we're using as well to try and mitigate that.
Yeah.
And for aerospace,
segregation is going to be a more major issue than it has been, I think.
Yeah, I think for aerospace as well, there'll always be a need to have the primary steel, and we'll find that the blast furnace goes on to a dry process with hydrogen, and that steel will cost a lot more, because obviously currently hydrogen is 6 times more expensive than natural gas. So as soon as we get into hydrogen, it puts the cost of the product up massively. But they might just have to pay that for aerospace if they want to have that purity of product.
But I'm assuming, as Daniel had that product report or that deliverable, there was an assessment with different fields. So when you decide to do an analysis on a specific product, or look to decarbonize and make that product a bit more efficient, one of the elements you will be assessing is the impact on the process and the outcome on the quality. I didn't look at the detail of the form, but certainly for us, pardon me, we will raise a management of change, and we will try to decarbonize and improve our processes, but we are validating at the same time the performance either of the product, or if it's a full system, the performance overall of the system itself, and then that will become a permanent change. So I don't know how that is done on the steel industry, but I would be assuming, Daniel, it will be a similar process. Pardon me.
Yeah, I mean, it's quality is not necessarily. I'm only talking from Tata UK perspective, but it's never really something that's seen as something that can be sacrificed necessarily, but more that you might aim to have a lower quality product for a certain application, and it might be that the uses for this product are more wide-ranging than its comparator, and that there's less that has to go into the processing of this product, hence that might lead to it being a kind of less upfront sort of carbon intensive product to produce. but I wouldn't say that it's like a causality that comes out of trying to decarbonize necessarily.
Right.
Yeah.
Well,
Thank you.
sorry, does that answer your question?
Yes, absolutely. Also the factor for Robert from British Steel as well. He also clearly
well-
mentioned that we need to care for regarding the raw materials because, you know, as a quality wise, we may need to get a certificate of the raw materials to get assure and ensure its quality. That's why we just need to make sure on it. Thank you.
Yeah, the problem will come with steels that really have to be formable, you know, the very mild steels that have to be formable for making tin cans and cold-headed components, things like that. That's where residuals become much of a problem.
There is a request, Daniel, if the guests who attended the meeting, if they could have a copy of your slides, if that would be acceptable.
Yeah, more than happy to share that if I've got
Yeah.
That would be great. I'll reach out to you and get a copy, and then Rimel, because of GDPR, if you see what I mean, we will give
Yes.
it to Rimel, and then she can facilitate that through the CQI and cascade the slides to the people who attended the meeting.
Yeah. Not a problem. Yeah.
Right. Are there any more questions? Or right. Well, look, that obviously you've presented a tremendous amount of information. It's been absolutely fantastic, really. Probably too much in the head at once, trying to understand all of it. But
there was a lot.
it was. I found it really interesting. The very busy slides, but you've really covered it quite well, and you've made people realise certainly that Tata are taking it extremely seriously and taking steps to go down the right route. As I know from other friends in the steel industry that everybody's thinking on those lines. Right, well, thank you very much. Our next event is on ISO 99001, which is actually constructional steel type of thing. The really ISO 9001 specifically aimed at in the language of constructional steel. So that's on March the 13th, is it, Marcus?
Yeah, that's right. Yeah.
March the 13th. So I look forward to everybody. Once again, thank you very much, Daniel. It was a lot to take in. You must have spent ages putting it all together. And congratulations on a good presentation. So I'll say, unless anybody else has got anything to add, I'll say we'll close the meeting now.
Have a good night, and Daniel, thank you for your support. Appreciated.
Thanks very much, everybody.
Thanks for the questions as well.
Good night.
Thank you.
Good night, everybody.
Bye.
Good night, everybody.
Yes.
Thank you all.
Thanks for joining.